Hi everyone. Now that we've covered all the different types of reactions in chapters 4, 5, and 6, I think it'd be a good idea just to go through and summarize each of them. Before you go through this video, be sure you've already watched those that I posted by Tyler DeWitt and Melissa Maribel, because they did a real nice job of going over 5 of the basic types of chemical reactions. So I'm going to review those 5 and then add a few more. And by the time we're done, there should be a total of 9. So the first one that they talked about and that we did in class was double displacement, which has your basic AB plus CD type of format. And there's 2 different types of double displacement reactions that we talked about. The first one is precipitation. So if one of the products is a solid in the reaction, then we have a precipitation reaction. The other type was an acid-base reaction. So if there's an acid and a base, and acids we usually recognize because they start with hydrogen, and bases because they end with hydroxide, and then we get an ionic compound and water. So under double displacement, there's 2 possibilities so far, and that's precipitation and acid-base. The second type of reaction we talked about were single displacement reactions, where an element reacts with a compound. So it has the A plus BC format. If A is a metal, it trades places with B, which is the metal, and if A is a nonmetal, it trades places with C. So here's a couple of examples. In this first one, since A is a metal, sodium, it switches places with the lithium, and the sodium ends up with the carbonate and lithium by itself. In the second example, element A is oxygen, which is a nonmetal, so it's going to switch places with arsenic, which is a nonmetal, and so the potassium will end up with the oxygen, and the arsenic will be by itself. And again, we balance the charges in each case. So in this first one, we put 2 sodiums with a carbonate to balance the charges, and in the second, 2 potassiums with the oxygen. The next type of reaction is called a combination reaction, and like the name implies, it involves combining things. So it has the general form of A plus B, giving us AB. And as you saw in the videos, there's 3 different possibilities. In one case, it can be an element combining with an element to form a chemical compound. In the second instance, you can have a compound and an element combining to form a compound, or in the third case, it can be 2 compounds reacting with each other to form a third compound. But in each case, they all follow that A plus B gives you C format. Decomposition reactions are essentially the opposite of a combination reaction. So instead of A plus B, it's AB breaking apart to give us A plus B. And I essentially just took the 3 reactions that I showed you on the previous slide and simply ran them in reverse. So any combination reaction is also a decomposition reaction if you simply write it backwards. So each of these 3 is simply running in the opposite direction of the previous slide. The next type of reaction is called a combustion reaction. Basically anything that burns is undergoing combustion. So combustion requires 2 things. You need a fuel, which is normally a carbon compound, and you need oxygen. And in any combustion reaction, the carbon always is converted to carbon dioxide, and the hydrogen, or the hydrogen and oxygen, are always converted to water. So combustion reactions are actually a little bit easier because the products are always the same. In fact, 3 of the components are always the same: the oxygen, the CO2, and the H2O. The only thing that differs is the fuel. So there's 3 different possibilities. In the first one, your fuel can be a hydrocarbon. This happens to be the formula for butane. But gasoline, jet fuel, natural gas, propane, those are all examples of hydrocarbons. So the carbon becomes CO2 and the hydrogen becomes H2O. Now the physical states of the fuel is not something I expect you to know. You should know that oxygen's a gas because it's on the periodic table, and from your own personal experience, you ought to know that carbon dioxide is a gas and that water is a liquid. The second possibility is a compound that has carbon, hydrogen, and oxygen. This happens to be the formula for glucose. And so when you burn glucose in your cells, it combines with oxygen to once again form carbon dioxide and water. And then the third possibility is a fuel could simply just be carbon. Some coal is mainly just carbon. So carbon can combine with oxygen to form carbon dioxide. Notice this time there is no H2O because there was no hydrogen in the fuel to start with. Now there are a few types of reactions that weren't covered in those videos that I posted from YouTube. First one of those is just a general redox reaction. So redox basically means that something gained electrons and something lost electrons. And so if a redox reaction doesn't fall into one of our specific categories of either combination, decomposition, or single displacement, we just use the generic term redox. So in this example, we started out with a cerium with a positive 4 charge and iron with a positive 2, and the cerium ended up at positive 3 and the iron at positive 3. So the charge on the cerium decreased, and that means that it was the substance reduced and also therefore the oxidizing agent. The charge on iron went from positive 2 to positive 3. So an increase in charge means that the iron was the substance oxidized and of course is also therefore the reducing agent. So any type of reaction in which electrons are gained and lost or charges change, we know it's some type of redox reaction, and if it doesn't fall into a specific type, the single displacement, the combination, or the decomposition, we'll just use the general term redox for it. There's also a generic form of double displacement reactions. So this first reaction with nitric acid and sodium acetate, it forms acetic acid and sodium nitrate. Now you'll notice that all 4 of these compounds are aqueous, and in the past we would have assumed that if everything is aqueous there would be no reaction. But the best way to be certain whether there's a reaction or not is to write the complete ionic equation. Now to do that we have to dissociate things that are supposed to dissociate. So for example, nitric acid is a strong acid. Strong acids is their nature to dissociate completely. Sodium acetate is an ionic compound. Ionic compounds, when they dissolve in water, have to dissociate. That's how they do it. Acetic acid, on the other hand, is a weak acid, and it's the nature of weak acids not to dissociate very much. So we're not going to dissociate that. And then sodium nitrate, because it's an aqueous ionic compound, it will dissociate. So we separate the hydrogen and the nitrate. We separate the sodium and the acetate. We leave the acetic acid as it is. We don't dissociate it because it's a weak acid, but we do dissociate the sodium nitrate. So if we look at the net ionic equation, the nitrates and the sodiums canceled out on both sides, but we couldn't cancel out the hydrogen and the acetate because the acetic acid did not dissociate. So even though everything was aqueous, clearly we formed a new substance, acetic acid, from the hydrogen ions and the acetate. And if you form a new substance, by definition, you have a chemical reaction. So since this is not precipitation and it's not acid-base, we simply use the generic term and just call it double displacement. One other possibility with the double displacement reaction is that there's simply no reaction. And that does happen at times. In experiment number 10 that you're working on this week, there will be some reactions that are no reaction. So the first thing, we look at the molecular equation, and if all 4 substances are aqueous, then there's 2 possibilities. It's either no reaction or the generic double displacement. So if we dissociate all the substances that should, which includes either strong acids or aqueous ionic compounds. So nitric acid is a strong acid, so it dissociates. Sodium perchlorate is an aqueous ionic compound, so we dissociate that. Perchloric acid is a strong acid, it dissociates. And sodium nitrate is an aqueous ionic compound, it also dissociates. If we cross out all of the spectator ions, the hydrogen ions, the nitrates, the sodium ions, and the perchlorates, they're the same on both sides. they all cancel out, and our net ionic equation is nothing but an arrow. So the best definition of no reaction is if it's exactly the same before and after, because a chemical reaction means you have to make something new. And if all of the materials at the end are identical to those you started with, you have no reaction. So predicting no reaction is pretty easy. You just need two requirements. Number one, all four substances are aqueous, and number two, all four substances are either a strong acid or an aqueous ionic compound. So we have two strong acids, two aqueous ionic compounds. In the previous example, we had acetic acid here instead of perchloric acid, which was a weak acid, so that meant there was a reaction. It has to be both strong acids or aqueous ionic compounds. And that is the 9 different possibilities. There were 2 in number 1, which was acid-base precipitation. And on the next slide, we'll go ahead and summarize all 9 of the different possibilities. Now, on the next quiz, one of the questions that you'll be asked is to complete and classify various types of chemical reactions. So there's 9 possibilities for the type of reaction. 4 of them fall under the double displacement category, 4 of them fall under the redox category, and combustion essentially stands by itself. So the first thing, if it's a double displacement type of reaction, it should have that AB plus CD type of setup. If it does, then it's going to be one of these 4, either precipitation, acid-base, generic, or no reaction. So it's pretty simple. If the double displacement reaction produces a solid, it's precipitation. If the 2 reactants are an acid and a base, meaning one of the compounds begins with hydrogen and the other ends with hydroxide, it's an acid-base reaction. Now, if all 4 compounds are aqueous, it's going to be one of these 2. If they're all aqueous, but one of them doesn't dissociate, meaning it's a weak acid, then it's generic double displacement. If all 4 are aqueous and they dissociate, that means that it is no reaction, and that'll happen if all 4 compounds are either a strong acid or an aqueous ionic compound. Combustion, of course, is pretty easy to recognize. You need fuel and oxygen. So if you have a carbon-containing compound plus O2, that's a dead giveaway that it's a combustion reaction. Now, redox reactions involve gaining and losing electrons, which means the charges of the ions change. That's an important difference between double displacement and redox. In a double displacement reaction, charges never change. In a redox reaction, charges always change. So you never want to get into that habit of thinking if I say always or never, it can't be true, because some things are always and some things are never. So if it's a redox reaction, there's 4 possibilities. First one, of course, is single displacement. If it has that A plus BC setup, where it's an element plus a compound, you know it's single displacement. Combination is when you put 2 things together to form 1. So anytime there's 2 elements coming together to form a compound, or an element and a compound joining to form a new compound, or it can even be 2 compounds combining to form a single compound. It's the many becoming the few. Decomposition is simply the opposite of that. Any combination reaction, if you run it backwards, it's decomposition. So it has the form AB arrow A plus B. So it's a chemical compound breaking apart into either compounds or elements. And then finally, a generic redox reaction simply means that charges changed, atoms gained or lost electrons, but it didn't fit into any of these 3 categories. So if it doesn't, we just go to the heading and simply call it a redox reaction.